have derived the formulas cos ix equals e raised to minus x plus e raised to x by 2. Number it is equation A. We also obtained sin ix equals e raised to minus x minus e raised to x by 2i. From where we have I times sin ix equals e raised to minus x minus e raised to x divided by 2. We are just taking I to the LHS and thus we obtain this relation. We can also write this as minus I times sin ix equals e raised to x minus e raised to minus x divided by 2, because in this equation if we multiply both sides by minus 1 we obtain this equation. Number it is equation B. We have already studied the expression of sin hx and cos hx. Sin hx equals e raised to x minus e raised to minus x divided by 2 and cos hx equals e raised to x plus e raised to minus x divided by 2. Number these expressions as equation C and equation D. We are now looking for the relationship that can be established between circular functions which are sin ix, cos ix and hyperbolic functions which are sin hx and cos hx. When we compare equations C and B, we have minus I sin ix equals sin hx, because you can notice that in equations B and equation C, both have same RHS. So we can equate the LHS. Thus we obtain minus I sin ix equals sin hx. If we multiply both sides of the equation by I, we obtain I times minus I sin ix equals I times sin hx. We can now replace I square by minus 1. Therefore, minus 1 into minus 1 becomes positive 1. Thus, we obtain the relation sin ix equals I times sin hx. Sin ix is the trigonometric function or circular function. Sin hx is the hyperbolic function. If we compare equations A and D, again you notice that both these equations have same RHS. Thus, you can equate cos ix equals cos hx. Now we have obtained relationship between hyperbolic sine and trigonometric sine, also hyperbolic cosine and trigonometric cosine. We can now establish the other relations that exist between hyperbolic functions and circular functions. We have tan hx equals sin hx by cos hx, but we have to convert this to trigonometric tan function. Therefore, we replace sin hx by minus I sin ix, which was the relation we observed when we compared equation B and equation C. We have cos hx equals cos ix. Now we multiply numerator and denominator by I. We have I square equals minus 1. Therefore, minus sign disappears from numerator. We also have sin ix by cos ix equals tan ix. Therefore, we are left out with I in the denominator and tan ix in the numerator. Looking at this relation, tan hx equals tan ix divided by I. By cross multiplying, we obtain I times tan hx equals tan ix.